Hello everyone. Today we are presenting our project AI-based one-stop health and fitness application. So basically, in this project, we develop an all-in-one solution by developing a mobile application, namely One Stop Fitness, which offers features such as diet recommendations and workout suggestions. Here we have tried out different recommendation models, and the accuracy and speed between them is compared. Next slide. These are the three recommendation models that we tried out on two different data sets, Amazon Fine Food Reviews dataset and the Food.com recipes and interactions dataset. Next slide. The first recommendation model that we tried out is using collaborative filtering, and we used singular value decomposition algorithm for that, and the RMSE obtained was 0.00995. Next slide. The second model we tried out using surprise library, and we tried out different algorithms, and the best performed algorithm was the SVD after performing hyperparameter tuning with an RMSE of 0.9181. Next slide. This is the third recommendation model that we tried using natural language processing. So here we find out similarity score using cosine similarity, and we use the threshold as 0.6 as a good similarity score between the recipes. Next slide.
So the previous three recommendation systems had very good recommendation results, but they were not feasible because each recommendation system had to rerun again for each individual user, and that was pretty time consuming. This model using Node.js and MongoDB logs user activity based on its search and weighs the item. So the more the user searches the item, the more the weight of the item. So the problem of rerunning the model again is solved here because the model learns from the user activity and logs it. Next slide. Here are the four classes that we use to implement the entire process of recommendation. First is the user activity. This class calculates the user's weighted score on the item based on search. Second is user similarity. This calculates the particular user's similarity to other users and groups them accordingly. Third is user recommendation. This class does the final phase of recommendation engine, which is to generate the recommendations of the users. Fourth is the user model. This class manages the entire schema of the query execution. Now my teammates will go through the demo of the app.
So we have divided our application into four different microservices. So this is the Docker Compose file for it. So we have user microservice, then workout recommendation, and the workout meal services. So in the index.js file, we have defined the recommendation algorithm, which Anuj has just explained. So these are the four models. And in the run function, we have defined, it basically calculates the user scores based on its other user similarity, and also it calculates the recommendation for them. So now Harshal will go through the demo of the application.
Okay, so this app is currently running on my phone. So this is the dashboard screen, and there are a couple of screens here. So this is the workout screen where users can browse or search through different workouts. And each of these workouts are only created by professionals. So each workout has a specific set of exercises, and each of these exercises could be viewed on YouTube to follow along. And apart from that, users can also create their own workouts based off of a lot of exercises. Here also users can search different exercises through uh, by focusing on different body parts. This is the community page where users can share different posts and add comments to it. So if a user can comment, so here you can see the comment is added, and the timing is shown in the order of seconds. This is the meals page where users can search for different meals based on keywords or specific meals. And each of these meals would have their specific nutrition values. So as you can see that the nutrition values are shown here for each of the meals. And this is the finally workout page where users can see their own workouts and also see the recommendations. So these are the recommendations generated for this specific user. And these are based on the weight values, as Anuj already mentioned. And you can see that it's showing the recommendations for this user.